Hello, my name is Caleb Bradley. This is Lab Experiment 8, Part 2. And what we have here is our 2 flip-flop circuit. Alright, so first things first, I'm going to explain how everything is wired. So starting off, we have our VCC, which is connecting to our... let me let it focus. Yeah, our VCC is connecting to our IC, to both of our flip-flops. We have our ground obviously connected to the flip-flops, and we have all of our J and K inputs which connected to red wires, and those are all connected to VCC. Next up is our set and clear for this entire circuit for both flip-flops. We have them connected to these data switches up here. So the blue wire connects to our clear, and our green wire connects to our set. And we have these two yellow wires down here are the clear and set of our second flip-flop. These also connect to our data switches up here. Note that both of these data switches are high right now. And next up, we have to explain our output. Okay, so we have two yellow wires here. We have one that connects to LED 7 and one that connects to LED 6. Our first yellow wire connects to the output of our first flip-flop. That goes to LED 7, as you see here, and our second one connects to the output of our second flip-flop, which connects to LED 6. So this is the output for A, and this is the output for B, which will count as our first and second flip-flop. And this green wire here is important because this connects the output of our first flip-flop to the input of our second flip-flop. And our final wire here is our clock voltage, our clock for the first flip-flop. This is where everything's manipulated. And just turn that on. And the whole point of these two flip-flops are to act as a counter. As you can see, there are two flip-flops, so using logic, we can determine that there are two binary numbers in here. We have one that is dependent on our first output here, and then another one here. This is our B and this is our A. So we can actually use this to count up to a specific number before resetting, because since there's only two. So the way this is oriented is that our B counts as our first 0. So this would be our 0 or 1, and this one would be for our second binary number. So for example, if this one is lighting up and this one is off, then we would have 1 0, which is 2. But if this one is the first one that's lighting up, then we will have, if this one's the first one lighting up and this one's off, then this will be 0 1, which is 1. Alright, so I'm going to turn this on and we're going to get counting. I'm going to toggle this 5 times, and you're going to see how it alternates between everything until it resets. So 1, 2, 3, 4, 5. As you can see, it didn't count all the way to 5. It stopped at 3 and then reset back to 0. And that's because this is a mod 4 counter, meaning that it has 4 different states, 0 to 3. And after it reaches that third one, it goes back to 0. It resets. And this concludes the demonstration for part 2 of our experiment 8.